Example 3 states that suppose two parallel lines are intersected by a transversal where the measure of angle 5 is equal to 63 degrees. Determine the measures of the other 7 angles. So parallel lines, recall that parallel lines are lines that run side by side. They'll never intersect. They kind of look like the rails on the railroad tracks. So I'm going to go ahead and I'm going to draw in a couple of parallel lines. There's one here. And don't forget that these don't have to be perfect as long as they kind of offer some clarity or a visual aid as far as what's going on. So here are parallel lines. They don't intersect. And then it says that the parallel lines are intersected by a transversal. And a transversal is a third line that cuts through the two parallel lines. It does intersect them. So I'm just going to put in a transversal here. And again, it doesn't have to be anything fancy. And what a transversal does is it then creates this series of 8 angles. And here they are up here and over here. And I'm going to label these angles 1, 2, 3, 4, 5, 6, 7, and 8. And what happens is these angles become categorized. The categories are, here are interior angles, 3, 4, 5, and 6. Interior angles seem to appear on the inside of the parallel lines. And then we have exterior angles, such as 1, 2, and 7, 8. Exterior angles appear on the outside of the parallel lines. So alternate interior angles, alternate means that they alternate from either side of the transversal. So alternate interior angles for this would be 3 and 6. And then the other alternate interior angles are going to be angle 4 and 5. Alternate exterior angles would be something like 1 and 8, and then 2 and 7. And what that says is that alternate interior angles will have the same measure. So 3 and 6 will have the same measure, and 4 and 5 will have the same measure. It also states that alternate exterior angles will have the same measure. So angles 1 and 8 will have the same measure, and angles 2 and 7 will have the same measure. There's also corresponding angles. Corresponding angles are angles that look the same if only one of the parallel lines was showing. So corresponding angles would be 1 and 5, 3 and 7, 2 and 6, and then 4 and 8. Also, there are vertical angles. Vertical angles are angles that are across from each other. So 2 and 3 will be vertical angles, and something like 1 and 4 will be vertical angles. Corresponding angles and vertical angles also have the same measure. So now that we understand all that, we can go ahead and start answering some of the problems. And of course, we're going to determine the measures of the other 7 angles. So this angle here, angle 5, is 63 degrees. So I'm just going to put that in right there. Now, what we're going to do is we're going to determine the other 7 angles. So right here, we could see that angle 5 and angle 6 are supplementary angles. So using our understanding of supplementary angles, that if we add the measure of these 2 angles together, it's got to equal to 180 degrees. So we'll do that. We have the measure of angle 5. If we add that to the measure of angle 6, that's got to come out to be 180 degrees. The measure of angle 5, that's 63 degrees. If we add that to the measure of angle 6, that's going to be equal to 180 degrees. Again, we'll use some simple algebra. We'll subtract out 63 degrees from here because we want to solve for the measure of angle 6. And we'll subtract out 63 degrees here. The 63 will cancel. 180 degrees minus 63 degrees, that's equal to 117 degrees. So the measure of angle 6 is 117 degrees. So now that we know that, we can fill out the rest of the other angles. If this is 63 degrees, this is a supplementary angle to angle 5. It's also a vertical angle to angle 6. And there's also a corresponding angle. So this is also going to be 117 degrees. this angle is going to be 63 degrees. We can see up here, 3 and 7, those are corresponding angles, so that's got to be 117 degrees. It's also an alternate interior angle from angle 6. So again, this has got to be 117 degrees. 4 would be a supplementary angle. 4 is also an alternate interior angle. So that's going to be 63 degrees. So you can see the type of relationship that these angles have. And we're going to use that later on to solve more sophisticated problems. So there we go.